All right. Page 2. So first one here is, or page 2 is all about a magnetic field around a wire. This is where all magnetism comes from, a moving charge or a moving electric field, but moving charge for this unit creates a magnetic field. And so step one, we want to draw the magnetic field around a wire. So first thing to recognize is that it's a circle. It's not a moving circle. It's a circle with direction on it. So you need to draw a circle. Now, sometimes we only draw the top and the bottom half of the circle, like we will down below here with the wire going to the left, or excuse me, to the right there. But if it's that, just a dot or the X of the dot, then we want to draw circles around that. So A, B, and C are referring to this current carrying wire to the right. I'm going to draw the magnetic field lines around the wire. So the field lines are circles. So I'll draw 3 of them. 1, 2, and 3. And I could jump right onto it and draw those directions, but some of the questions, well, let's just do it. All right, I'll take my hand here. All right, I'm going to put my thumb in the direction of current. Now that's going to be into the page. I don't know if I should draw it at you. I think it's at you. I don't really know how this would work. If you're going to watch it, that's coming out of the page at you. So I guess technically it would be this way into the page, away from you, and then you curl, but then the video is flipped. You know what? Let's not look at this. Make sure you use your right hand. Make sure you use your right hand, and then get some practice with this during your review day. So right hand rule, that's an X. X means into the page. So I'm going to take my thumb and I'm going to point down into the page. When I do that, I end up curling my fingers clockwise around that. Ooh, that last one should go that way. All right, and then yeah, I mean you can label how many different spots you want. I don't know. Well, might as well finish it off here as well. All right, that's that. Um, so that's that. What direction is the current traveling in the wire? This is just asking you to interpret that X. That X means into the page. What direction would the magnetic field around the wire? We just said was clockwise after we drew it, so it is clockwise. The magnetic field, B, is around the wire. So that's current right there, I. Field is B. All right. So then we take the wire, we run it to the right there. So I'm going to take my thumb, I'll draw it to the right, and I will curl. If you want to try and draw it 3-dimensionally, I'm not going to stop you. You just start kind of there. Maybe that. This is not a very good one. Normally I get a little bit better job there. So that's kind of a circle around it. It's hard to draw that, but then if I drew that, I would need to be coming out of the page up here, kind of down in front, and then back that way on that. That's going to be very hard to interpret. I'll do my best if you draw it that way, but if I can't tell, I can't give you credit. A very simple way though would be to draw that cross-sectional area here. So what if you cut it right there and right there? Actually, I don't know, would you cut it maybe here? I guess you'd cut it there. Let's undo those. You cut it, you slice it there and there. What does it look like? Well, up here above the wire, my fingers, as I curl, are coming out of the page. So those are dots. And I see the tips of my fingers. I see the tip of the arrow there. And as I curl around that wire across the top and back down into the page, I see the feathers of the arrow, the backs or the X of the arrow. My knuckles or the X's there. And that means into the page. So out of the page, into the page. Good. All right. E. Now we're asking what happens if you at the different points, I think. Or no, that's later. If the direction of the current, the direction changes. So if the direction of the current changes in the wire, what happens to the magnetic field? Well, you could try it. Take your finger, your thumb, go to the left, curl, and you see your fingers curl into the page on the top, out of the page on the bottom. So the field would reverse. The field reverses. All right. That'd be good. Again, justification, you could just say right hand rule number 1 or right hand rule for a wire. All right. Now point P. If I move P further away, so what happens if I take P and I move it twice as far? So if I move P up there, well, the equation for magnetic field around a wire is some sort of constant. I'm not writing it. You can look at your equation sheet. It's some sort of constant with a 2 pi on the bottom, and I believe a permittivity of empty space on top. But the key part is that it's I over R, right? So if I increase that R down there, if I increase R, that's going to decrease the field. And so by exactly 1/2. So it'll be 1/2 as large. Twice as far is 1/2 times as big. All right, if point P were the same distance, so we're not moving it far away, but below the wire, what would happen to the magnitude of the field? It would be the same magnitude. Right? Same magnitude, but reverse direction. But it would be, I guess, let's not say reverse direction. Let's say into the page. So if you move P down, it will be into page. Into the page. All right. And then what about if we tripled the wire's current? So again, reset here, triple the current, and again, back to the B is proportional to I over R. This is why I like the proportionality things here. Right now we're going 3 times here. So since those are directly proportional, it'll be 3 times the B. So it'll be 3 times as big. All right, and that is field around a wire.